For us to be able to apply the expanded written method of solving multiplication problems, an important thing that we need here is our skill of identifying the place value of digits at all times. Let me show you what I mean from the first example A. If I want to solve the first example given here, which is 56 multiplied by 4, first, I'm going to set out my arrangement as if I want to use the formal written method. So I'm going to write 56 with enough space in between them times 4. Now, something very important you should know here is the place value of each of these digits making up the numbers to be multiplied. Here, 6, for example, is in the ones place, while 5 is in the tens place. So it means that when I want to multiply 6 by 4, I will be multiplying exactly 4 by 6 or 6 by 4, assuming or knowing fully well that 6 is in the ones place. But when I want to multiply 5, because 5 is in the tens place, I'm not going to say 4 times 5. That will be wrong. Because actually 5 being in the tens place means that this is 50. You get the point. So I'll be multiplying 4 and 50. In that case, 4 multiplied 6 give me 24. Remember how to place your values. The 4 is in the ones place, while the 2 comes in the tens place. 4 multiplied 50 is 200. So I'm going to write 0, 0, 2. 2 is now in the hundreds place. Having reached this level, the next thing to be done is to add my digits at this level. So I'm going to add 4 plus 0, which gives me 4. 2 plus 0 gives me 2, and I'll bring down the 2. So my answer for multiplying 56 by 4 is 224. Another example will help you better. This time around, we are multiplying the numbers 47 by 6. Now remember your place value. 7 is in the ones place, while 4 is in the tens place. This means that when I want to multiply 7 by 6, I am multiplying 7 by 6 with the full understanding that 7 is in the ones place. But when I want to multiply 4 by 6, I am not multiplying it just as 4, a single digit. Knowing that 4 is in the tens place, this simply makes it 40. So I'll be multiplying 40 by 6. So with that in mind, first when I multiply 6 by 7, that gives me 42. So my 2 is going to be in the ones place and 4 in the tens place. But when I multiply 40 by 6, this is going to give me 240. How did I know this? I know this because 6 times 4 is 24. Bringing 0 to it makes it 240. So write it exactly the way it should be in the place value. So my 2 takes the place of 100. So I'm going to keep 100 place here. Now it's time to add. 2 add 0 is 2. 4 add 4 is 8. And then the 2 comes down. So it means that when I multiply 47 by 6, my answer is going to be 282. It's as simple as that. But let's try it out on 3-digit numbers. Here we have the number 276 to be multiplied by the number 9. Now, a simple thing you should know is your place value. 6 is in the ones place, 7 is in the tens place, 2 is in the hundreds place. To begin, I'll be multiplying 9 and 6. And to do that simply means that I'm multiplying 9 by 6 in the ones place, which is exactly 6 as it is. Now, to multiply 9 by 7 in the tens place does not mean 7 as a single digit, but that implies multiplying 9 by 70 because 7 tens make 70. And also multiplying 9 by 2. 2 is in the hundreds place. So I'm not just going to say 9 times 2. No. Rather, I'm going to look at the place value, which is 100. So this is exactly 9 multiplying 200. Now, with this in mind, we set out our multiplication this way. 9 multiplied 6 in the first case is going to give me 54. Since 54 is a 2-digit number, it means I have just tens and ones. 4 in the ones place and 5 in the tens place. Nice. 9 multiplies 70. You can first of all say 9 multiplies 7. That's going to give you 63. Now remembering the 0 and putting it together makes 630. So that gives you 6 in the hundreds place, 3 in the tens place, and 0 in the ones place, 630. And finally, 9 times 200. First, 9 multiplied 2 is 18. Then, putting the hundreds to it makes it 1800 or 1800s. To write that, the first 0 comes in the ones place, the next 0 in the tens place. Now, 8 is going to be in the hundreds place, while the 1 comes in the thousand place. Now, with this in mind, it means that our place value is extended to the thousand. Now we can add. 4 add 0 and add 0 is 4. 5 add 3 is 8. Add 0 remains 8. 6 add 8 is 14. I'm going to write it as 4, while the remaining one comes exactly right to the digit in the thousands place. So 1 add 1 is going to give me 2. So my answer for multiplying 276 by 9 ends up being 2484, as you can see it here. Expanded written method is actually not difficult, but you have to master the act of using the place value. Now let us solve 439, our next example, by 5. To work this out, place value is going to help you like it has always done. So first of all, our place value, we have the ones place, the tens place, and the hundreds place. To begin, we set out our multiplication. 5 can multiply 9 first because 9 is just a single digit. After this process, 5 is going to multiply 30, not 3. The reason is because 3 is in the tens place and 3 tens make 30, okay? And finally, 5 is going to multiply not just 4, but 400. How did you know that? We know that because 4 is occupying the place of the hundreds. Okay, so to proceed further, we're going to write out the digits or the answers rather that we get for this multiplication. All right, so 5 times 9 is 45. Write it properly. 5 in the ones place and 4 in the tens place. 5 times 30 is 150. That simply tells us that 1 is in the hundreds place, 5 is in the tens place, and 0 is in the ones place. The next number to be multiplied is 5 multiply 400. First, we can say 5 times 4, that's 20. But remember the double zeros to make it 2000. It means there is going to be 1,000 place value coming further because our answer now is 2000. So the other zeros are distributed according to their place values. Now add your answers. 5 add zeros is 5. 4 add 5 is 9. 1 add 0 is 1, and the 2 comes down freely. So it means that when we multiply 439 by 5, we end up with the answer 2195. Can you try solving 475 multiplied by 7? Try working out this answer with expanded written method. And do not forget to post your answer in the comment section. As always, keep watching Whiteboard Math Party. See you later.